Hello, welcome to Maths with Lloydie. Got the sponsors, Grace Hockey, Heroes. We're into question 6, is paper 2C on the, I think, 2017 paper. I've actually forgotten which paper this is. Yeah, 2017. So, capacitors are used in electronic circuits. The charge on a capacitor can increase and decrease and is measured in coulombs. Coulombs? In a particular circuit, the charge on a capacitor increases for 1 millisecond and then decreases for 1 millisecond. The charge Q coulombs at time t milliseconds after the capacitor starts to charge is given by. So here you've got this formula for between 0 and 1, and you've got another formula between 1 and 2. Work out the charge of the capacitor when t equals 0. So to show this, I'll look at the e bit first. E to the negative 3t becomes e to the negative 3 times 0 is 0. Therefore, that's going to be e to the 1, right? So e to the 1. That's going to be e to the 0, which is just 1. And then in that bracket, you do 1 minus 1, which gives you 0. And when you multiply it by 6, you still get 0. So for this question, it's 0. Okay, part B. Show that A equals 5.7 correct to 3 significant figures. So what I'm going to look at here, and I've noticed this with the inequalities, is that they are equal when time is 1. So the left-hand side, 6 open bracket 1 minus e to the minus 3 is going to be equal to A, e to the minus 3 open bracket 1 minus 1. Now with this whole bit is going to just be 1. Because 1 minus 1 is 0, times it by minus 3, it's still 0, and e to the 0 still equals 1 from earlier. So that's just going to be A. Then we have 6 take away 6 lots of e to the minus 3. From there, we can probably put that into our calculators. I'm going to work that out. Just apologise now before I sneeze. That's a nightmare. Probably hay fever. So e to the minus 3 times by 6, and then 6 take away, the answer is 5.70127759, and that's quite important because it's a show that question, but you're showing that it's correct to the 3 significant figures, so we need to show the accurate value before it's rounded in order to show that we've mathematically done it correct, and that's that for part B. Right, part C. Sketch a graph to show how the charge on the capacitor varies during the 2 millisecond period. Now, what you can do for this is you can substitute in some values of 0.5, of 0.2, or whatever, and then you'll work out that this has got a bit of a shape to it, to there, and then the other one will come down like that. Now, just put that through. With this, we've got t equals 1, so we've got to show all of our areas. We've got 1 to 5.7, which is that maximum point. And then where t equals 2, we've then got to figure out what this bit is. So if we go back to our equation, I've just tried to swipe left, that's no good. Into here, we've got 5.7 lots of e to the minus. Now 2 minus 1 is 1. So it's going to be 5.7 e to the minus 3. And then once you put that into your calculator, you'll get 0.284. And you just need to show that as well so that we can describe what's happening. Okay, part D. The circuit designer wants the charge to be less than 4 coulombs for at least 60% of the time. So if I just draw with a red pen, they want to see how much of it's going to be below that dotted line, but we can't use our graph to describe that. So within this, I keep saying seconds, but it's milliseconds, isn't it? Does the circuit satisfy this requirement? So the first thing I'm going to work out is, just need to have a little think. Okay, I'm going to work out the time it is at 4. When does it reach 4 at the start? So at 4 is equal to 6, 1 minus e to the minus 3 over t. That's the time we need to find. 4 divided by 6, I'm just going to quickly simplify. That's 2 over 3. So I've just, rather than expand out the bracket, I've just divided by 6. I'm then going to subtract 1. Oh no, I'll add the e bit. So that's going to become positive, e to the minus 3t. And I'm also going to take away the 2/3 to give me 1/3. Then if we apply the natural log, we get rid of e, and then minus 3t will equal natural log of a third. And then by dividing it by minus 3, that will get us to our final answer. So let's now calculate that. So ln 1 over 3 divided by minus 3 gives me t equals 0.366. Okay, next bit, let's work out when it hits 4 on the way down. So 4 equals 5.7 e to the minus 3 t minus 1. 4 divided by 5.7 will equal e to the minus, I don't know what that is, so 3t minus 1. Apply the natural log. 4 over 5.7 equals minus 3t to the minus 1. Then we need to divide it by minus 3. And then I need to write all of this out again. That's crazy. Add the 1 on, and that gives me t. Okay, let's put that into the calculator. Okay, t will equal 1.118. Now that's when it hits, we've just worked out sort of that bit. We've just worked out that bit. So if we do what I'll call t2 minus t1, so this one, 1.118, take away 0.366, that's going to tell me the time that it's above this line. So 1.118, take away 0.366, that is 0.752. Now 40% of 2 is equal to 0.8, and therefore it does satisfy the requirements because it's below 0.8. There we go. Right, that's the paper done. Good luck for your exams. Hopefully you're consuming all the content on the channel. I wish you luck, and I'll see you next time.